So if I had time, I would talk about a second myth, which is also in its sunset, the myth of formally verified distributed components. And sort of the TLDR of this is that we're not going to be able to model check or formally verify our systems for the same reasons that we can't rely on experts, because it's not possible to compose fault tolerance out of pieces, okay? We couldn't model check all of Netflix. The state space is too large. So our best hope would be to model check the pieces and put them together. And as I already argued, that didn't work. And so industry and academia alike have raced on this trade-off space from the left, which is sort of exhaustive but intractable approaches, to the right, incremental but arguably unprincipled approaches that combine well-understood testing methodologies with fault injection. We run our integration tests, and while we're running our integration tests, right, we crash shit, and we see what happens. I think this is an interesting shift, because it's a fundamental shift towards understanding how our systems behave, not from the inside, as an expert would understand them, or a model checker would understand them, but from the outside, accepting the fact that in the limit, these systems must be treated as black boxes. But black boxes whose inputs and outputs are very well understood. So instead of shining a spotlight in the box, we walk around the box, and we watch it take in inputs and produce outputs, and we formulate hypotheses about its functionality based on its behavior. That's actually kind of cool. Right now, of course, we can't just test how our system works under every fault, because there's too many faults, right? If I have an application involving 100 communicating entities, there are 100 different, and we're just looking at crash failures, there are 100 different things that can go wrong to one thing, right? 3 million things that can go wrong with 4 things, 16 billion things that can go wrong with 7 things, and for all 100, guys, that's 2 to the 100. That's a 1 with like 30 zeros after it. We can't actually perform all those experiments. We need a smart way to search this space. Now, we could sort of stab into the space randomly, as early chaos approaches did. But we're not going to cover the space very well or get any confidence that we're exercising the right faults. It's tempting to ask, could we rub some genius on it? Could we exploit the intuitions of people who understand the systems under test to take a sort of genius-guided walk through this space, visiting only the interesting failures? But, of course, this should give us the heebie-jeebies, because it requires a genius in the loop. Now, 2 giants have emerged in this space of principled approaches to testing combined with fault injection. Chaos engineering, over on the left, as exemplified by Nora Jones, formerly at Jet, now at Netflix, chaos engineer extraordinaire, and Jepsen testing, as exemplified by Kyle Kingsbury, the creator of Jepsen, and as far as I know, the only Jepsen tester in the universe. And these things are different, okay? And I've written down some of the differences here, but I think that we can gloss over them, right? They apply to systems at different scales, with different challenges with respect to availability of source code, and obviously a different gold standard of what it means to be correct. But if we ignore these minor distinctions, they are the same thing, right? They involve a combination of principled observations and targeted fault injection, right? But they require the acquisition and retention, not just of super users, but of like ultra users, of one-of-a-kind, irreplaceable geniuses. And that's no good.